All right, now we have to stop and pause for a moment because I want to know, do you have a good attitude? Because this problem is kind of a pain. It's kind of a pain in the tuchus. Okay, so this air glider collides head-on with a glider, and they stick together because, well, in the lab we have Velcro that does this, right? What is their post-collision speed? How much kinetic energy is lost in the collision? So what we're going to do is we're just going to figure out the velocity afterwards, right? And then we're going to figure out the kinetic energy of the whole system before, kinetic energy of the whole system afterwards, and we're going to subtract. Okay, but yeah, there it is. Okay, so let's draw a picture of this. Here's this glider gliding along, and I'm just going to make this go to the right. So it's going that way at 0.120 meters per second, and it's got a mass of 0.220 kilograms. And here's the other glider. It's bigger, and it's going negative 0.38 meters per second and has a mass of 0.410 kilograms. Okay? So this guy's going this way. This guy's going this way. Okay, and then afterwards, of course, they collide. And we've got a little bit of Velcro in there that helps them stick together. And they're going V, and this is the mass of that's going to be 0.22 plus 0.41. Dare I say that that's 0.630 kilograms? Now, there's no question this thing's going to be going to the left. This has more mass. This has more velocity, so it's definitely going to go to the left. But let's figure that out. Okay, so that's our first thing, right? So 0.22 times 0.12 plus 0.41 times negative 0.38 equals 0.63 times V. Let's solve for V. All right, I can do this. 0.22 times 0.12. Wow. Okay. Dyslexics beware. Okay. Plus 0.41 times negative 0.38. All right. I'm getting like negative 0.1294 here, and then I'm going to divide by 0.63. And I get, okay, look at this is a good sign. I'm getting this answer here. So my velocity is negative 2.0, oh no, negative 0.205396 meters per second. Now I'm writing down a ridiculous number of sig figs because when I do the calculation of the energy, I don't want to round this, okay? Notice it says what is their post-collision speed. Okay, so I don't really need to say what the direction is. I just need to say what it is. Now, it's fine. Just say which direction it's going. Although I didn't tell you which way these gliders are going, only that they hit each other head on, right? Okay, but that's fine. I'm just going to ignore minus signs or directions because we don't have that, right? But when you do this, when you find out the kinetic energy, don't round this value, okay? Okay, so my kinetic energy here is 1/2 0.22 times 0.12 squared. The formula I'm using here is 1/2 mv squared, right? Okay, plus 1/2 0.41 times 0.38 squared. I'm purposely not putting that minus sign on there because it doesn't matter, right? We're going to square it. But just be careful. Don't put it in there because your TI calculator will evaluate the expression incorrectly unless you put the parentheses. Okay? So 0.5 times 0.22 times 0.12. And honestly, kids got it wrong because they put the minus sign in there and didn't put parentheses. Okay? Let's see, plus 0.5 times. I'm going to sue TI calculators for all the points that my students have lost because they couldn't evaluate. They couldn't evaluate this expression correctly. It'll say that that's -4, which is not correct. All right. I'm getting that this energy is 0.0 0.03116, whoops, 86 joules. Not a lot of joules, right? That's 0.03186 joules is what I tried to write there, but evidently had a hard time. So that's the total energy before. Let's figure out the total energy afterwards. It is easy, right? That's 1/2 0.63. And then it's this whole thing here. So 0.205396. Again, if it's negative, be careful, don't, put parentheses around it when you square it. So 0.5 times 0.63 times, and then I got to go parentheses because my number ended up being negative the way I did it. Let's square that thing. And I actually just used the whole number. I went up arrow with my calculator, and I get that the energy afterwards is 0.013289146 joules, right? This is clearly less. It'll always be less if they stick together like that. And then the loss of energy is 0.031186 minus 0.0132. I'll just say 9. I'll go 8917. All right, let's figure it out, man. This is the moment. This guy minus, some people have just fallen asleep by now, right? The screen is going. They're just falling asleep at home listening to this video. I'm so sorry. Okay, I'm getting this is the exciting conclusion, 0.1789 joules. Okay, because you've been such a good audience, and that's the answer, 0.0179. So again, just figure out the velocity, right? Figure out that velocity, then figure out all the momentum on the left side. There's gonna be two things moving, so add them together, right? And then at the end, just be careful, don't round this. Don't round. You'll throw the baby out with the bathwater, and that baby's gonna get angry with you, okay? Now, since you've been such a good sport, I'm gonna tell a joke, okay? It's a knock-knock joke, so you say knock-knock, right? And I say, who's there? And you say, Europe.